Hello, I'm David Boyer with Danfoss Drives, and I'm going to explain how to implement the sleep mode feature.
Please take a moment now to pause the video to read the safety warnings shown here. Failure to follow these warnings could result in death or serious injury.
Sleep mode. This feature is intended to save energy and extend equipment life. During times of low demand, when the drive is running but not producing any flow, it's economical to stop until needed. When running in open loop mode, that's where the speed is commanded by an automation system. Sleep mode is based on low speed detection. When running in process control or closed loop mode, that's where the drive calculates speed based on a feedback signal compared to a set point. Sleep mode can be triggered by either low speed or low power detection. Let's talk about low speed detection in open loop mode. What's it take to go to sleep? It's been running for at least a minimum runtime and has been at or below the specified low speed for a specified delay time. What are the conditions for waking up? Well, you have to have been asleep for at least the minimum sleep time, and the speed reference exceeds the wake-up speed. Using the MCT10 setup software, I've made a collection of all of the parameters pertinent to sleep mode. Let me show you quickly how I did that. If you choose a drive down here in the project, right-click and do New Parameter Folder, it gives you this folder that is empty, and you put in it any parameters you're interested in. You just highlight, right-click, copy, go to your folder, right-click on ID, and paste. Hit OK, and that's how I made these collections. Let's delete that folder and move along. All of the sleep mode parameters. The configuration mode, whether open or closed loop, affects other parameters and certainly how the drive runs. Your motor low speed limit 412 affects the ranges of some of these other parameters. 2220 low power. Once we talk about low power detection, you need to tune that. You can have the drive do it automatically using that function. You can sleep based on power or speed, enabling either of those. And if once you detect that low power or low speed, what do you want to do? Sleep mode is one of the choices. There's that delay time. It's got to meet the conditions for that time before it goes to sleep. Here's where you define at what speed low speed is detected. This is a data readout that we're going to put in our display. That's if you're using low power detection. It'll give you a readout of what low power means at whatever speed you're running. Here's where you can make an adjustment to your low power settings. Here's where you would manually adjust your low power and low speed points, your high power and high speed points. We'll look at those more closely in a minute. There's the minimum times we talked about. If you're running, run for at least that long. If you're sleeping, sleep for at least that long. If you're sleeping based on speed, here's the speed you wake up at. And then notice these three are blacked out. If you are using low power detection based on a feedback, how far do you want the feedback to drop before you wake up? How far do you want to boost that pressure a little bit before you go to sleep? And what's the maximum time you want to do that? Now notice here, if I change to closed loop, these become available and the wake-up speed is no longer shown. So that's an overview of all the parameters. Let's see how they work. Okay, we'll start with the simple example of running in open loop control and set up low speed detection and sleep based on that. Over here we have a drive. Let's see what our numbers in the display mean by hitting info. Top left is reference unit, meaning that when we run in open loop, that'll be our speed command. When we get to closed loop, that will be our set point. Top middle is no flow power. That displays the threshold for falling to sleep based on low power detection. Because you can only show that in kilowatts, we're going to show our motor power to the right of it in kilowatts. Middle of the screen shows the speed that the drive is running. And in the bottom middle, it will show feedback unit for when we get to closed loop. Let's set up our parameter. Okay, we'll stay in open loop mode. Motor speed low limit parameter 412. Notice our no flow speed is 0, our wake up speed is 0. If your motor speed low limit is not 0, we'll put in 15 hertz. These can't be lower than that. So this is the threshold at which we declare no flow low speed. Let's make it a little higher than the low speed limit, and we'll put it at 16. Notice the wake up speed can be lower than the sleep speed. If it's ever the case where both the sleep condition and the wake condition are true, wake condition takes precedence and it would continue running. This is not a good practice. You would want this higher than the sleep speed. We'll make it 20 hertz. So go below 16, go to sleep, and stay sleeping until you get above 20. Our no flow delay, that means below 16 for how long? For this demonstration, let's make it faster. Minimum run time, anytime you're running, before you consider going to sleep, go at least this long. We'll make that 5 as well. Whenever you're sleeping, sleep at least this long. We'll make that 5 seconds as well. And we need to enable the low speed detection. What do you want to do when you detect low speed? We want to go to sleep. So running our drive, we'll give it a start command. Got a speed reference of 32 hertz. It ramps up. So if we ever call for less than 16, it should count to 5 seconds and go into sleep mode. Which it does. It'll stay sleeping until we get above a 20 hertz command, and it wakes up. So that's the very simple open loop mode low speed detection. Now let's look at running in closed loop with the pressure feedback. Here's the pertinent parameters. First thing we're going to do is change to closed loop. Now we still got the same 15 hertz low speed limit. Low power detection is now enabled, and when that happens we're going to go to sleep. The same 5-second delay. When we're sleeping based on low power, we need to define low power. And so what you would do either is do it manually, create the no flow condition by turning off valves, and then put in a low speed. Recommended is 50% or 30 hertz. Run at 30 hertz in that no load condition and record the power. Same thing here, high speed, run at 85% speed, which would be 51 hertz, and note the power and record it here. Alternatively, you can have the drive do that automatically. Let's just do that and see how it looks. We can't access that from here, so we go into the 2220 low power auto setup from the keypad, enable that, and hit OK. And it gives you this screen. Has your low speed limits been set? Yes, right here. Hit OK. It wants to know, have you closed the outlet valve? Yes. So we'll give it a hand on, and now it will automatically run up to 51 hertz. Remember, this is the power readout, and so it's going to notice that at 51 hertz and make a note of it. It then runs to the other speed automatically down to 30 hertz, records the motor power again, and when it finishes it will save those values. Press OK. And here we can see it recorded that 30 hertz. It put in the 0.05 horsepower that it measured at that speed. It put in the 51 hertz and entered the 0.12 horsepower it measured at that speed. That defines the no flow, low power detection threshold. We still have our minimum runtime and sleep time at 5 seconds. Now, when we're running in closed loop and going to sleep, it's going to wake up rather than at a speed. It's going to wake up at a difference between reference and feedback, and it's in percentage. We're at 10%. We're going to give it a set point of 30, and so that means it would wake up when the pressure drops 10% below 30, which would mean 27. Boost set point. That is, when the sleep condition is met, it's going to speed up and boost the pressure up above set point by 10%. So it's going to speed up and bring the pressure up to 33 before it goes to sleep, so that it can allow for some leaking or pressure loss and sleep longer. And it will only try to do that for this time. Right now it's set for 25 seconds, but it can be up to 10 minutes. So now, let's run the drive and see how it handles. Okay, we're in standby. When I give the start command, the drive will begin increasing speed, trying to increase the feedback to meet the set point. And there it goes. There would be the actual motor power and the threshold at which it would declare no flow based on low power. I'll simulate an increasing feedback. Notice this number will change a bit based on speed. It's 0.06 now. It takes, it's a higher threshold at a higher speed. So we're near set point. Let's go a little above set point so the drive will start slowing down. Once it reaches a no flow condition, I'm going to simulate that by dropping the load some. We're below the threshold. It should start counting that 5 seconds and then go into a sleep boost mode, where it's trying to increase this pressure to 33. We'll simulate that going up to 33 and instantly goes to sleep. Because of this 10% wake-up difference, it's going to continue sleeping until that drops to 27. Let's drop that to 27. And it wakes up. Now let's show here. Remember I said that if both the sleep condition, that would be actual power below the low power threshold, is true at the same time that the wake condition would mean that pressure is below 27. If they're both true at the same time, that's below 27, that's below the trip threshold, it'll never go to sleep. If I increase this above 27, you go into your boost immediately. Drive's going to increase speed. It can't much more than 60 hertz already. Once it gets to 33, it goes to sleep. Once the pressure would drop below 27, it'll wake up. And it does. So that's the basics of sleep mode. You've got familiar with all of the parameters involved. My demonstration isn't real life, so it's a little manipulated and not great, but we saw it do what it does. And if you have further questions about that, 888-DANFOSS is the tech support number, and they can answer anything specific that you run into. That's it. Thanks for listening.
Thank you for viewing. We hope this information has been helpful. Danfoss drives can provide additional technical support, parts information, or repair services options by contacting us through one of the following methods. For immediate access to customer service or a technical support expert in North America, call 1-888-DANFOSS or 1-888-326-3677 or contact us through email. For technical support, the email address is drives.ts.na@danfoss.com. For customer service, the email address is drives.cs.na@danfoss.com. For after-sales service, the email address is drives.ts.service.na@danfoss.com. Additional information is also available on our website at www.danfossdrives.com. For contact information in areas outside of North America, please visit our global website at www.danfoss.com. Thanks again.